Hi, I'm going to go over how to find the focus of a parabola today without having any previous formulas memorized. I'm just going to look at the definition of a parabola based on a focus and a directrix. Okay, so if we have a parabola here, let's say the parabola is of the form y equals some constant times x squared. And I start with that because it's simple. I like starting with a simple case. And there is a point above the vertex called the focus, and we're going to label that point 0, a. Right? And we call that the focus. And that focus has associated with a line underneath the parabola called the directrix. And I'm going to label that directrix y equals negative a, and you'll see why I'm thinking negative a in just a second. The definition of a parabola is given a focus and directrix. It is the locus of points, or the group of points, such that if you measure the distance, and we can use black for this. If you measure the distance to any point on the parabola from the focus, and the distance from that same point vertically down towards the directrix, let's call this distance f and this distance d, then those two distances should be equal to each other for any point that you pick. So I'm going to pick, as arbitrary as we can get here, x and y. Right? Call that our point. And it should be true for any x and y that you pick. F should be equal to d. Let me just write that down here. F is equal to d. Okay. Writing down f equals d is good, but it doesn't really help us that much unless we put it in terms of x and y. And how do we do that? Well, what we do is we refer back to Pythagorean theorem, right? We know if we measure f this way, right? We can't measure that directly in the Cartesian plane, but what we can measure is this. We can look at how much does x change, what is the distance in the x direction, and also how much does y change, what's the distance in the y direction. Those are at 90-degree angles with each other. And so applying the Pythagorean theorem, we see that delta x squared plus delta y squared is equal to f squared. Okay? And now what we need to do is figure out what delta x and delta y is. Well, what we do is we look at this, we say delta x, how much does x change going from the focus to the point on the parabola? Well, that would be our point x minus 0. So x minus 0 is just x, and we go ahead and square that. So that's our delta x squared. Our delta y squared, we look at how much does y change. Well, we're at y over here, right? And we're at a over here, so y minus a should give us our distance in the y direction. Okay. And we set that equal to, now remember this is f squared, and so f squared is equal to d squared based on f being equal to d. We have to do the same thing for d squared, right? Well, d squared, we look at the change in the x direction going across this way. And there is no change, right? It's a vertical line, so change in x is equal to 0. We forget that. All we look at is the change in y. Whereas y up here, it's at y equals y, and down here, y is equal to negative a. So y minus negative a is actually y plus a. Y squared should be equal to d squared. So here we have f squared equals d squared. Let's go ahead and expand this thing. We've got to go ahead and erase this. Now we'll expand this equation, so we have x squared plus y squared minus 2ay plus a squared is equal to, expanding the right-hand side, we have y squared plus 2ay plus a squared. Right? Subtract a squared from both sides, those cancel. Subtract y squared from both sides, they cancel. Subtract 2ay from both sides, and we have that. X squared minus 4ay is equal to 0. Right. That's a good start, except we've got too many variables for it. But we happen to know that y is equal to cx squared, so I'm going to rewrite this using, I'm going to write x squared minus 4ac x squared equals 0. And we can factor in x squared. So I have that x squared times the quantity 1 minus 4ac is equal to 0. What does that tell me? That tells me if x equals 0, a can be anything it wants, which makes sense, right? I picked this so that, you know, a units above the vertex here and a units below the vertex here. I could let a be anything it wants as long as x is equal to 0. But the interesting case is when x can be anything it wants, 0 or otherwise, right? Let's say x is up here. Well, what does that mean according to this equation? That means that the 1 minus 4ac also has to be 0, right? If this isn't 0, then that better be 0. So we write down 1 minus 4ac equals 0, which means that if you solve this for a, right, you get that a is equal to 1 over 4c, which is helpful, right? I'm going to go ahead and erase under here. Get rid of that. Right, now we can write this point as 0, comma 1 over 4c. And we can write this line as the equation y equals negative 1 over 4c. Right. So that's good. If we have an equation of the form y equals some constant times x squared, we can figure out what the focus is and what the directrix is based on these two formulas. Except that we don't always get a parabola in this form. We don't always get the vertex being located at the origin. Sometimes the vertex is located somewhere else. So what I want to know is what happens when we shift this parabola. Let's say we do a shift, right? Let's say we go alpha units in the x direction, right? Let's say we go up beta units in the y direction. Oh, what's going to happen? How are we going to rewrite this equation? We're going to write down y. And in order to shift up beta units, we have to subtract beta directly from y, right? And that gives us a shift beta units in the y direction. And that's equal to c times x. And in order to shift x alpha units in the x direction, we have to subtract alpha directly from x. And so we get that equation. Right? Except we usually like the thing solved for the y on that side. So I'm going to write down y equals c x minus alpha y squared plus beta. And consider that my new equation of a parabola, right? If you know, what we started out with was that alpha and beta are both equal to 0. But here, this is a parabola with its vertex located at alpha comma beta. And if we have that, right, all we need to do is shift the focus and the directrix in the same direction, right? Alpha units over and up beta units. So our new focus here is going to be, let's go ahead and add alpha onto the x, right? So alpha plus 0 is alpha. And let's add beta onto the y. So beta plus 1 over 4c, or 1 over 4c, plus beta is our y coordinate of the focus. And to shift the directrix up by beta units, all we do is say directrix is given by the line y equals beta minus 1 over 4c. And if you know how to complete the square, you should be able to take any equation of the parabola and put it into that form, and from that you can get your focus and vertex. And if it's a sideways parabola, you just switch the roles of X and Y. That's about it. Thanks.